Okay, one more question I am supporting. After that, you will do. Question number 6 is that question number 6, right? What volume of oxygen would be required to burn completely 400 ml of acetylene? You know, acetylene is what? Acetylene, right? Acetylene is the rival name. Basically, it is ethine, C2H2, right? It is C double triple bond C H and H. Its tribal name, right? Acetylene of C2H2, and this is it is called ethine, right? So now this C2H2 undergo oxidation. So oh my god, how much volume of acetylene is there? 400 ml. Okay, 400 ml of 400 ml of acetylene. It combines with oxygen, right? It combines with oxygen. This is take in bracket, combines with oxygen. So how you can get, and again we get the in in every hydrocarbon like alkane, alkyne, on oxidation they produce two things only: carbon dioxide and water, right? For all alkanes, CO2 plus H2O, right? So now how you will do this? First of all, there is 3, carbon is 2. So if I take 2 here, so it becomes 2 carbon, 2 to the 4, 1 5. Hydrogen is 2, carbon is 2. If I take 2 here, 2 to the 4, so I have to take 2 here also, 2 to the 4, now 4 carbon. So I'll go with 4 carbon here. So 4 carbon molecules, 4 carbon here, 4 carbon here. Hydrogen is 4, 2 to the 4, hydrogen 2 to the 4. Fine. Now oxygen is 4 to the 8 to 10. So we take it here 5. Now it is clear. It is balanced, right? It means 2 ml of acetylene combines with 5 ml of oxygen gives you 4 ml of carbon dioxide, right? Did you understand? And my equation is balanced. Akhand, is it balanced? Okay, good. So now you have 400 ml of acetylene. So what it is asking for? Calculate the volume of carbon dioxide formed. Okay. So carbon, this is in liquid form, this is in gas form, this is gas, and acetylene is also a gas, right? So 4 ml. Okay. So now we will apply simple unitary method. I hope you understand. C2H2 and carbon dioxide gas, right? 2 ml of carbon dioxide ethane gas combines with 4 ml of carbon dioxide. So 400 ml of ethane will give us carbon dioxide, that will be 400 into 4 upon 2, 2 to the 4, it becomes 800 800 ml of carbon dioxide. 800 ml of carbon dioxide. Carbon dioxide comes out. Is it correct? Done? Very good. Okay, you are very slow. Anyway, take your time, take your time, take your time. So, the next question we have, uh, can we go? Next is question number 7, right? It is asking for oxygen also. No, also volume of. Okay, what volume of oxygen required to burn completely? Oh my God! Why not you tell me? You asked me earlier. I was going to rub. Anyway, so again, same place there. C2, H2, and O2. So 2 ml, 2 ml combines with 5 ml, right? So 400 ml will combine with oxygen. How much? That is 400 into 5 by 2. Is it? So how much it will be? 200. It becomes 1000 ml. Is it correct? 1000 ml of oxygen, right? So final product is with 400 ml of acetylene, 1000 ml of oxygen combines and give us carbon dioxide, that is 800 ml. 800 ml. Fine. This much. This is the result. Final outcomes. Right. I'm going to rub this. Okay. So one question came in 2018. That is question number 8. We should try for that. I hope this is question number 8. It comes in 2018 ICSE board exams, right? And it is saying ethane, C2H6. That is called ethane, right? Combines with oxygen and gives you balancing. This is quite difficult, yeah. CO2. Akan, can you balance this? H2O. Can you balance this equation? Do it, do it. Don't see the book. There is 6. So we should take 3 here. No, 3 is not. So We should take 6 here. 6 2s are 12. Here we take 2. 2 6 are 12. So carbon is here 4. So I'll put 4 here. So now, where is my, wait for white. Carbon height. Carbon is 4. Carbon is 4. Hydrogen is 12. Hydrogen is 12. Fine. Oxygen is 4. So 4 plus 2 becomes 4 plus 2 becomes 8 and 6 14. So we took 7 here. Took 7 here. Right? Akan done? Okay, thank you. So this is gas, this is gas, this is gas, and this is liquid. Forget about this. So it means two. What is given? Parameter are 1, 1, 7, 2. Okay. Okay. This is in cc. So 2 cc of ethane combines with 7 cc of oxygen give us 4 cc of carbon dioxide, right? So now if we take, and it is given us uh, uh, 300 cc of ethane, 300 cc of ethane, 300 cc of ethane, and 1250 cc of oxygen, right? Volume of unused oxygen. Okay, so again we go for unitary method, but one side I'll write C2H6, another side I'll write oxygen. So 2 cc combines with 7 cc of oxygen, so 300 cc, sorry, 300 cc will combine with how much oxygen, cross multiply and division. So 300 into 7 upon 2, it becomes 150, right? So how much it is? 15 sevens are 105. Yeah, 1050 cc. This much oxygen is used, right? This much oxygen is used. So unused oxygen is unused oxygen is 1250 cc. Out of that 1050 cc, so we get 200 cc. 200 cc of oxygen unused. Getting? Right? And how much carbon dioxide you are getting, man? How much carbon dioxide you are getting in this process? That again you come to the point that if I go with ethane, C2H6 and CO2, so 2 cc of ethane combines with 4 cc of sorry, 2 cc of ethane gives 4 cc of carbon dioxide. So 300 cc will give how much carbon dioxide? Cross multiply and division. So we get how much? That is 300 into 4 upon 2, 2 1 ja 2, 2 2 the 4. It becomes 600 cc of carbon dioxide formed, right? So what will be the total volume of mixture? Total volume of mixture is total volume of mixture is CO2 600 cc plus oxygen 200 cc. So therefore 800 cc of total volume of mixture, right? That is 800 cc. Is it correct? Done? You both done? Okay. So okay. So should I rub this? Should I rub this? Okay. We will talk little bit about uh, you know vapor density. Do you know what is vapor density? Say yes or no. Okay. Akhil, do you know? Okay. So vapor density vapor density is equal to weight of weight of 1 liter of gas at STP upon weight of 1 liter of hydrogen at STP, right? This vapor density is comparison of 1 liter of gas at STP upon weight of 1 liter of hydrogen at STP. Fine. And vapor density, or you can write it like this also, that in simple language, vapor density is equal to weight of given volume of gas upon weight of same volume of hydrogen. I hope you understand. Okay, na? Whatever is the weight of given volume of gas upon weight of same volume of hydrogen, right? That is called vapor density, right? And we have molecular mass. molecule, we have a relation, very classical relation we have, that molecular mass molecular mass molecular mass is equal to 2 into vapor density. Vapor density, right? Molecular mass is 2 into vapor density, right? So what is empirical formula? Empirical formula, right? Empirical formula is simple whole number ratio of elements, atoms of elements, atoms of elements, elements present in a molecule, right? It is simple whole number ratio of atoms of elements present in a molecule. That is empirical formula, right? And when we uh, add their masses, so empirical formula mass is equal to sum of masses of elements, atom of elements, right? Now n is equal to molecular mass, which you get from here, molecular mass upon empirical formula mass, right? Understand? Hello. So molecular formula is equal to whole empirical formula subscript n. This is the formula, right? From empirical formula we get molecular formula by this method. These are the formulas which we will use. All of you have written? Very fast, yeah. Okay. Should I rub this? Fine. To get empirical formula, to get empirical formula, you know, say carbon dioxide is how much? 58%, right? And oxygen percentage is 42%. So how much of hydrogen will be there? How much of hydrogen? Should I bring it 48? I hope 10%. Is it? Who left? Who is there? Who is not with me? Okay. Battery goes down. So you are going to discontinue? Oh, sorry for inconvenience. Anyway, I'm just finishing in just 5 minutes. So this is percentage. You have 100%. Adrika, 48 plus 42 becomes 90. 90 plus 10 becomes 100. Right? 100%. 100%. Fine. So now here we write element. Right? Element. Then we write percentage. Then we write atomic mass. Then we write relative number of atoms, relative number of atoms, and then we have simple whole number ratio. Simple whole number, simple ratio, right? Okay, this is the table we have. Now first we have, first we have carbon. Percentage is 48%, right? Oxygen, there is 42%, and hydrogen is 10%. Is it? This much we can draw. It is not required. Close the table like this. Now, what is the atomic mass of carbon? 12. Oxygen 16. Hydrogen 1. So, can you tell me what is the relation? Relative number of atoms में क्या होता है? Percentage upon atomic mass. Do you know or not? I hope it is percentage upon atomic mass, right? So relative number of atoms. So it is 48 upon 12, 4, and this is 42 upon 16. 16 से 2 जा 48 ना, 16 2 जा 32, 10 0 100 20 10 point 16 6 जा 96. 4 0 16 2 0. Okay, fine. Now 10 divided by 1 becomes 10. So इसमें smallest क्या है? It is approximately 2.6. So 4 divided by 2.6, how much you get? Can you do it? Adrika, gone? Hello? हाँ तो how come 4.2.4? It is 1.66. 1.67. 26, so 26 divided by 26. 26 divided by 26, we get 1. And 10 and 10 divided by 2.6. It is around 0. It is 4. 4. It can be written as 2 as such, right? So empirical relationship empirical formula is equal to C2H4O, right? This is empirical formula. 2 is for C, H is for 4 for H, and for O 1. So we get empirical formula is this, right? So what will be the empirical mass? Empirical mass will be 12 2s are 24 plus 4 plus 16, right? It becomes 20, 44, right? So if molecular mass is 132, if molecular mass is 132, right? Or vapor density is 66, then N is equal to molecular mass upon empirical formula mass. So that is 132 upon 44. It becomes 3, right? So molecular formula will be is equal to empirical formula subscript n. So that is C2H4O subscript 3. So we can write C6H12O3. Getting? This is all arbitrary. arbitrary numbers. I have taken in a random order. So, but the process is like this, right? I want to teach you the process how we get, right? So how we get the empirical relationship, empirical formula, how we utilize this molecular mass or vapor density, because vapor density is 2 into molecular formula. So you get the molecular formula 132, right? And then we use this we get N is utilized here, and then we get molecular formula. Adhika, did you understand? और क्या नाम अखंड समझ में आ गया what I told you? So